whether you really understand or not, or anywhere you want me to, to put more focus on, to more emphasis on, emphasize on. Okay, so without further ado, we just pick up the from Monday's where we left. So we talked about the history of the international trade literature, right? So anybody remember like what is the first paradigm of the international trade research? It's called Neoclassical trade theory, right? So that's the first paradigm of the international trade field. And what about the second one?
New trade theory.
Very good. Who is speaking?
Mel.
Okay, Mel. Yeah. And what is the characteristic of the new trade theory? Instead of using the supply side model, new trade theory is focused on the demand side, right? And it's led by Paul Krugman's preference utility model, right? And what about the next one? The next one that's a very funny name. That's called New Trade Theory, and that's led by Mark Mellers. And that basically is the development of this field. So we will start from the neoclassical trade theory today, and the very first theoretical model we are going to study is called Ricardian model, and we will see later on. Oh, actually, no. Sorry, the first one we have to complete the whole introduction. So the first one will be the gravity model, which is not very well covered in our textbook. So let's go back to the slides. A little bit of a review. The neoclassical trade characteristic, the characteristic of the neoclassical trade model. The first one is perfect competition. We talked about this last time. What is the mathematical equation that could resemble this perfect competition? So okay, yeah, go ahead. Sorry, go
yes,
ahead. Yeah.
So its price equal to the marginal cost.
Exactly. So its price equal to the marginal cost, right? Okay, but in the microeconomics, when we talk about the perfect competition market, what else is something that we are focused on? We mentioned if the market is perfect competitive, what the market have? Usually the goods are identical.
There's a constant return.
Okay, very good. That's the second one. And the production follow the constant return to scale, right? Which is our second point here. So in mathematical equation, what does it mean? If you have a production function like this, y denotes your output, f it's your production function, and you have two different production input. Here it's labor and capital. What does it mean? Constant return to scale means if I double up, okay, so I have k, or not k, if I have t times of the labor and t times of the capital, what will the output be? Will be
TY.
Ty, right? So a very simple of this functional form will be L plus K equal to Y, right? If it's a linear, you scale up your production input, you will get this, right? Use the, what's this? Rule of the distribution, right? So you will get this. Okay, so this is the other important facts in the perfect competitive competition market. What else? What about the firm's behavior? Confirm exists and enter the market easily.
No barriers to entry and exit.
That's right, yeah. So perfect competition, the other fact is there's no barrier to enter the market. Right? So everything you see here will be applied to the Ricardian model that we are going to talk about today. All right, and that's things in perfect competition market we are going to talk about is no distortion. Okay, so no distortion in microeconomics. What does it mean? Means in the market there's no transportation cost. Right, so transportation cost doesn't count into the market behavior, and there's no tax. Right, and what else? There's no price floor or price control things. So this slide is actually a very good preamble for today's lecture because we are going to look at the Ricardian model, which is the oldest model in a trade theory. Okay, so let's move on to next one. Do you need some time to take the notes, or you're good right now?
I'm
You need
good,
time?
right?
Yeah, if you need time, just let me know. Otherwise, if uh, I move on, this will be erased. Okay? So, law of the comparative advantage. So this is the today's the most important things. Countries are tend to export the goods. Okay, exports the goods in which they have the comparative advantage. So later on, you will see comparative advantage means what? Means this goods had smaller opportunity cost. Okay, and then the Ricardian model tells you that after doing the trade, you will have the gains from trade. So what does it mean? It actually means that the utility of both countries will goes up, and we will see why later on. Okay. A little bit of the empirical thing. You know, like everybody knows that neoclassical trade theory. It's a very important thing, important, and it's a it's a breakthrough, breaking through. You know, it's just a very important. Uh, you can say it's a paradigm or it's a new theory at that time. But a lot of people try to try to use the empirical research to identify the comparative advantage, and they are going to face some of the problem. The first problem is it's really hard for us to just focus on a single pair of the trade partner. For example, the model that we are going to see today, either the gravity model or the Ricardian model, both of them they only look at the two countries right now. But as you know, the world has a lot of a country. If we only partially focus on two countries, some of the facts cannot be captured. Okay? And the second term is the data variable problem. What does it mean? So a lot of the things, autarky means no trade, right? So latent variable means what? We in the Ricardian model believes that the relative price and the opportunity cost is the only things that behind a trade force. But this is not the case in reality, right? As you could think about it, what else could play a part in the firm's behavior? So there are some of the literature in trade field that, for example, the law enforcement, the quality of the court will be a big factor for the firm's decision to trade, right? If you are the firm from the US, you would like to do the business with the firms in the country, and their law are relatively fair. You don't want to be like your property is not protected. Your property will be collected by their government as you invest. So this kind of things jeopardize the effectiveness of the empirical test of the comparative advantage. And the third thing, the last but not the least, is the the pure autarky period is actually rare observed. Okay, so if you already read the homework assignment, that paper used one of the very unique time in. Oh, I shouldn't reveal. That's the homework question. Okay, so there's certain time in our world, and there's a country. Um, Somehow they have the policy to lock down their country. So that is a very rare case because whenever you see the trade data from now on, from like uh, the trade data uh, nowadays, um, it's really hard to find like one country which is locked on. Maybe North Korea could be, but their information disclosure will be another big issue for the researcher. Okay, so the one of the famous paper here is the Alan Diedorf, his paper. He tried to uh, downside. If you are interested in this one, you could go Google by yourself to take a look of this paper. He tried to downplay the problem 2 and 3, and then finally his results are uh, people think that his results are the first one to test the comparative advantage. Okay, so how does he do so? He used P is the vector of the price for the goods. So vector just means a bunch of different price. So if you have like 5 different goods, 10 different goods, then you will have a price vector of 10. That's it. So the easiest thing for him, he tried to test this equation holds or not. Okay, so what does it mean? Uh, the price vector during the autarky time, during the no trade time, times the trading goods after the country opened up. If this one is smaller than 0, means the country have the gains from trade. And the reason is because PA doesn't move, right? And Y it's the total production of the country. And C is the consumption of the country. So Y minus C should equal to T. Right? So if you move C to the left-hand side, what you get? You will get PA times Y minus C, 0. So this means the total production of a country times the total consumption of the country. And that's could be like, could be treated as the excess production in a country, right? So if there's a net trade float here, P should be smaller than 0, and that's how he do it. Okay, just take a look of the paper if you are interested in. And I just want to finish up the last part that we didn't cover in the first lecture. Okay. So let's move on to the gravity model. Okay, so if you already preview the lecture or the chapter 2 of the Finstra and Taylor, there are some of the reasons that we think it's the force of the trade. What are they? I think there are 4 or even 5, right? So the first one is the main topic later on today, which is Ricardian model. That's the differences in technology, right? And what about the second one? A country they are trade with each other. It's because
resources.
okay, so good, Ryan, thank you. So resources differences will be another one, right? So the first one will be difference in technology. And this is the thing that we are trying to explore later on today. The second one is the differences in resources. So sometimes the trade literature will refer resources as a country's endowment. Okay, and this will be the main topic we are going to explore in Heckscher-Ohlin model. What about the third one?
Offshoring.
Okay, the ability of the offshoring, right? So what's the meaning of the offshoring?
Basically, it's like the cost of producing various parts of a single good across different countries and then bringing them back to the final location.
Yep, yeah, exactly. So what are the example that we talk about on Monday? It's a good example of the offshoring of the U.S. firm. Will be iPhone, right? iPhone have a lot of chips or parts are coming from different countries. They assemble in the towns in the southeast part of the China, the coastal cities in the China, and then they export it back to the United States. So offshoring could be what? Could be treated as the ability of the country's firms to globalization. The ability of globalization. Last but not least, why we are talking about the gravity model here. And this is something that in our textbook, they didn't cover it a lot. The first reason maybe is because this is a relatively um, new literature, the branch of the literature in the trade. But something is important, and we mentioned this on Monday as well. So country trade with tend to trade with each other more if they are closer, right? So proximity is another important proximity factor. The geographic distance between a country is also a very important factor um, of the trade, right? Think about it. Using the example in the textbook today, in the textbook of the read, using the example in the reading for today, um, the snowboard in the United States, the import of the snowboard of the United States, the top 5 countries, who are they? The first one are China. The second one are Austria. And the third one is the UAE. The fourth one is Taiwan. Fifth one is Canada. Right? So among those big import country here, which one do you think is the effect of the proximity close to the United States?
Canada.
Should be Canada, right? But proximity will be the only reason or not? It's just partially the reason, right? Because if you think about the proximity as the main factor, why not Mexico to be one of the large trade partner in terms of the snowboard in the U.S. Right? That's the exactly the textbook's example. Okay, so we are going to explore one of the new theory right now in trade. So if you go to the international economics seminar right now, I think 80% of the people will talk about this. It's based on this model. It's called the gravity model, and this is the also called the Arlington model. Okay, so first of all, let me move on. So when I first studied this in my graduate study course, I feel like, oh, that's really strange because the gravity equations that in my mind it was physics, right? So what is the gravity equation means? So looks like this, right? So this is based on Newton's law, right? So this means that's the force, and G. Oh, wait, I forget. We have the space engineering space engineer here. I think it's Christy, right?
Yeah, I'm here.
So you should be able to explain this better than me. What is G?
G is gravitational constant.
Right, so it's a coefficient, right?
Yep.
Okay. So what is this cap M?
It depends on exactly what system you're studying, but it's the mass of one object in the system. So, for instance, if you're studying a satellite going around the Earth, then that could be the mass of the Earth.
Okay, very good. Exactly. And what about this small n?
That's then the mass of the second object in the system. So, in the same
Okay.
example, that would be the mass of the satellite.
So if you have two objects and one is bigger mass, one is a small mass, the law of the gravity tells us that they will have some of the force between them, right? Can I use force as a term here? Force between them, and this is uh, in proportion to the gravity coefficient and gravity coefficient and mass of the one of the object and mass of the other object. And the most important thing is what? Is the distance between them. Okay? And this Jan Tivergen, it's a Dutch economist. Somehow he find out that the trade between two countries could be represented as this kind of a format as well. So isn't it a little bit surprising? Yes or no? This is what his proposal looks like. So TAB is the trade value between country A and country B. We can say it's trade value or trade value between country A and B. And this notation means is proportional to. So it's not exactly the equal sign here, but you could treat it as an equal sign for now. And it's proportional to the GDP, so it's the total income of country A. And this is the total income of the country B. Right, so now you could treat two countries as two objects, and their mass is their GDP. And the most important thing is this is the product of their GDP to the power divided by the distance to the power. Okay, so the next question will be, what does the alpha and beta and gamma looks like? Right, and how do we use the data or empirical studies to test it? Does this looks weird? One more question. One more question for you guys. Okay, yeah, it will be a little bit right now, but so remember that what we are trying to do right now is to capture why the distance between a country is a force to make the trade happen. Okay, because the neoclassical theory already tells us that endowment, the technology, the offshoring ability, globalization's ability will be there. There are some of the models to explain that. The proximity wasn't introduced or covered by our textbook yet, and this is the hot research zone right now. Like it's a hot topics right now. One more question for you guys. Why do you think that the mass of the country is the total production? Or the total income of the country? Think about that.
The easiest thing to measure and compare two countries.
Say that again.
You're saying, is it the easiest thing to measure between two countries? You have to compare.
Well, think about that. If you're importing the goods, where are they going to? They are going to your domestic market, and they are going to be consumed by your citizens, right? So there's one term called domestic absorption. If you have taken macroeconomics, undergraduate level macroeconomics, you probably heard this term before. So domestic absorption using Simon Kuznets' national income equation, it's equal to this three terms, right? So these three terms, two of them might depend on the total income of the country. So that's the reason why they believe that the trade value between the country depends on the total income of the country, of the origin country, and the total income of the destination country. Right? Because you imported the goods, either the government will consume it or the consumer will consume it, or those goods are going to be the investment goods. And the level of the consumption is based on the level of the income of the country. And so is the government spending, right? The richer country tend to spend more dollars on the government spending. So they will import some of the goods from other countries too. So that's the background of Tegenberg's proposal here. Oopsie. So, like I said, the next question is how do we test the power here? What's alpha? What's beta? What's gamma? Right? So in econometrics, the easiest way is to take a natural log of the both sides. Right? If you're taking a natural log of the both sides, this one will be natural log P at B equal to alpha natural log GDPA plus beta natural log GDPB plus negative gamma distance. Right? So once you have the data between country A and B, and you have the GDP of country A, you have the GDP of country B, and you could also using any kind of a geometric calculation method to calculate out the distance between the country, then could you run a regression like this? And to estimate alpha, beta, gamma equal to what? You can, right? It's easy to do so as long as you have like a very large sample size. Not only with the country, if you have the more finer data between the cities, you could try to run the trade value between the city based on, oops, here's a typo here. Suppose there's GDPA. Based on the destination city's GDP and the sorry, this should be origin city's GDP, and this is the destination country's GDP, and their distance. And to see if your result is consistent with the theoretic model that Jan Tiebergens proposed at 1960s. Okay, so a lot of empirical study has already been done. You know, Distier and Keefshead has the research on this one too. So they believe that alpha and beta are stable and close to 1. So they have like a large data set, large panel data set across the different time, across the different country, and that's their result. And the other part of the other critics of this model, right? We try to capture the proximity as a force behind the trade, but there's some of the critics, you know, what is that? Can you feel that? We only take a look from the angle of the country. There's no micro foundation, right? So we don't know if the consumer in country A and consumer in country B are the same, and their consumption behavior, we didn't talk about that. We didn't discuss their resource budget constraint as well. The only thing we look in this model is the income for two countries and the distance of the two countries. So a lot of people started to criticize that this is not sufficient because so many ideal assumption was made. So if we want to really use this model as an analysis tool, we need to develop more on a microeconomic foundation. So that's Anderson, Jim Anderson and Eric Van Koop's contribution here. So they try to using the firm's behavior or the representative consumer's behavior to show you that the trade value between two countries will be actually proportional to their GDP, their income, their price level, and all kinds of the labor condition. And we will go over later on today. So let's just dive into the model. Okay, so this is the general form of the trade gravity equation. So as you could see, a lot in the trade literature, Xijk is the general form. So sub IJK means what? I means the origin country. Origin country. Origin country. And J is the destination country. Okay? And what's K here? This is just the general form. So K means in some of the industry. So you see, if I have one subscript here, I actually create another dimension. Now I can see the car industry and the computer industry. They have the different, this one we call a demand shifter. Very similar to the gravity coefficient, Newton's coefficient in physics. So this is something determined by the industry. Okay, so by building this, we could have very specific data point right now. It's the trade in industry K from country I to country J. Okay? Okay. Xij is the bilateral trade value of good K exported from country I to country J, or the value of imported goods to country J from country I. So those two statements are equivalent with each other, right? Export from country I to country J means imported from country J to country I. Okay, and remember when it comes to this notation, the order matters. So xij is not going to be equal to xji. If those two are the same, what do we call? We have mentioned this one on Monday night. The exporting goods from the country J to country I is equal to the exporting goods from country I to country J, means the JI's exports and imports are the same. What do we call? We call trade balance between country I and country J, right? Okay, so that's basic, that's it. And just want to show you the reduced form. If we get rid of the industry, so remember, what is the difference between this one and this one? This is the general form, and this is just the reduced form. The reduced form is the simple one, right? Now, I don't want to see any kind of the industry right now. I just want to see the country. So the bilateral trade value of the goods exported from country I to country J, or the value of the importing goods of country J from country I, it's this. And they are equal to, A is a coefficient once again, and their products of the product of their GDP divided by the distance. Okay, so one more thing. Here, the distance is not always referred to the physical distance. A lot of research right now has focused on the intangible things. So what kind of the distance could be? For example, languages. Languages could be a distance between a country, right? So if you are the English-speaking country, you tend to trade more with the English-speaking country. If your official language is Chinese, probably you want to trade with the Chinese-speaking country more. What else?
Shared currency.
Maybe that's a good point. Very good point. Yeah, currency will be like you have a common median of the exchange. That's exactly right. And cultural will be another thing, right? So as you could see, the proximity in our textbook, they didn't cover too much on it. So actually, proximity right now, how to measure the proximity is the current development of the trade research field right now. So if you are interested in this one, I have already this branch of the literature already posted one of the additional reading, and it's posted on I think it's a week 1 lecture 2's folder, and you could take a look. That's the notes written by Trabe Allen. So it's Trabe Allen. His first name Trabe. Yeah, Trabe Allen. Akalakis. So the first part of today's lecture, I'm going to go over some of the very basic gravity model to let you know why this provides a micro foundation of the gravity model. Provide a micro foundation of why proximity plays an important role in international trade. So let's take a look at some of the empirical evidence here. So you can see this is from Eaton Corton's textbook, which is very well-known trade economist too. So what is here on the vertical axis? It's the import value, and here it's the total absorption, right? So here is you could treat it as related to the country's total production. So as you can see, if the scatter plots look like a 45-degree line like this, what does it mean statistically? Means this and this are positive correlated, right? So the country's import and the total absorption of that country or Y of that country are larger than 0. So means what? Means if your country is bigger, you will import it more. Okay, so that's the meaning of this graph. And this graph tells you what? Tells you, let's see, what's the y-axis first? It's the share of the expenditure on goods from country I in country N. So xn is the total trade value. So import value in country N. Xin is the import from country I to country N. So this is the number of the proportion here. And x-axis is the gross production of yi. So this is the exporters' income, exporting countries' income. Okay, so what does it mean? It means that right now, in current days, people import the same goods from different kind of a country. So as you can see here, one of the country might have the ratio like this. One of the country might have the ratio like this. One of the country might have the ratio like this. So you will import a lot of the different, for example, in the US, importing the car from all around the world. So Germany's car probably give you like 10%. Asian's car probably give you 5%. So you will have different proportion of the importers. That's basically this graph telling you. So this one is tell you that bilateral trade and distance have the negative correlation. Okay, so let's take a look of the y-axis. The bilateral trade index is defined like this. What is it, this one? Let's take a look of the numerator first. XIN and XNI and XIN. What's this? That's the bilateral trade value, right? So this one is trade value export from country N to country I, right? On the other hand, this one is the trade value export or import from country I to country N. Okay, so this is the product of their trade value. And what is the denominator term? Denominator term, XII, means their domestic trade. Domestic trade means their production, GDP, right? So this term, bilateral trade index, if it's higher, means the country are trade more. So country will trade more. Trade more is their bilateral trade index is high. Okay, and let's take a look what is on the x-axis. X-axis is just the distance between a country. Okay, so what does it mean? You see that if you draw using an OLS or any kind of, or just using your naked eye to take a look, this pattern looks like this. All right, so if you have two different variables and they are like something looks like this, what does it mean? It means the covariance of the x and y are smaller than 0, or x, y are negatively correlated. So in a plain word means what? Means distance going up, bilateral trade index will go down. And that means the trade between these two countries will go down. Okay? So this is kind of the evidence shows you that trade really is associated with the distance. Okay, so here, a little bit of a conclusion. First one, the gravity model or the gravity equation is successful at explaining a large fraction of the variation. Oh, where's on? Sorry, typo. Observed bilateral trade flow. Secondly, geography plays a crucial role in trade pattern. Third one, the statistical model is not sufficient to answer the counterfactual question. What is the effect of reducing a border tax? So you see the critics here. If we look a little bit detailed inside of the model, how does the tariff come into play here? If we simply see this, where's the tariff? No tariff, right? So this model need to be adjusted a little bit, or at least to need to be developed. So Armington is the first one use the micro foundation to introduce this model. Everybody's okay right now?
Yeah, Professor. Okay. I have a question. Can you
Go
hear
ahead.
me? So this is just a baseline for looking at the relationships between two countries, right? Obviously, we're starting to chip away at some of the issues with it, but in terms of international trade, this is just a border. This is just a baseline, and then from here we can springboard onto other things, correct?
Yes, yes,
Okay.
you can see it. Yeah. So this is supposed to be covered on Monday's lecture. I try to be like part of the introduction. So this is the modern trade theory. So like you said, this is just based on like the borders, based on the countries exactly. So we didn't talk about anything of the firm's behavior or consumers' behavior. But after this, because of the Armington's contribution, so we could combine the country's consumer behavior and using the economic logic to analyze the trade between the country. Does that answer your question?
Because I was doing some work earlier today, and I was going forward to try to just do some problem sets, and so I was looking at like international trade equilibrium, and obviously what we're explaining now doesn't explain all of that. It's just like the base models and the base equations, and then slowly over time.
So this one, yes, I understand. Yeah, this one's not covered in the in, in the textbook, but we will cover Ricardian later on. This is just the additional one. I try to, show you what's the field development right now. What's the trade model we are looking for use. Right? A little bit complicated, but this provides you the micro foundation for further analysis. But obviously, this is not very similar to the neoclassical model that we are going to discuss later on today. Yeah. Okay, so let's dive into the model here. So first of all, this is the general form of the utility function of in country I. So you can see that S is the set of the countries in the world. So UI is the utility function, and this is the constant elasticity of the substitution function form. So this term means what? Means sum of all j's, right? So if you expand it out, that will be AI1. And sigma is just the elasticity of the substitution uh, across the country. Right? So what does it mean? It means the representative consumer in country I is based on this. The exporting goods they export to country J, and this is the demand shifter. So a rational consumer try to maximize their utility. Sorry, here should be utility, not demand. And this is the resource constraint in country J. right? So most of you take the microeconomics before. If I have the utility function like this, and I have the budget constraint or resource constraint look like this, what is the next step I should do? I should set out a Lagrangian multiplier equation like this, and then find out the first order condition, which is take the partial derivative, right? So if the consumer could, if the representative agent in country I, they could decide what's the value they are going to export to other countries. For example, right now they are going to export to country J, and then try to find Qij. What's the maximum? What's the optimal value of the Qij? So the first step you are going to do is to take the partial derivative with respect to Qij. Okay? And it's the same thing. If you have another agent or another country that's equal to icon, so you need to take the first derivative with respect to Qij and set it equal to 0. Right? So this is just the standard way that we figure out the optimization value in our consumer theory. If you have a U, you have a budget constraint, right? If you have a U, you have a budget constraint. You need to set up a Lagrangian multiplier equation and then take the first order condition with respect to the goods you are looking at. And that's exactly what we do right now. So you will give two first order conditions like here. So FOC stands for first order condition. Right? So if you take partial derivative of L is this equation, partial derivative of L with respect to Qij, what will you get? Take a look at the first term. We need to move down the polynomial, polynomial calculus, right? We need to move down the power first. Apply the chain rule. And the power -1, that's equal to this. Right? Do a little bit of the calculation. Right? Then this is exactly what we get. Take the first order condition by taking the partial derivative with respect to Qij. Maybe I write it again. Maybe that's better. Let me try to pull up the whiteboard. Whiteboard. Where is it? Whiteboard. Whiteboard. Okay. So this is the Lagrange multiplier. Lagrange multiplier is equal to this. right? Your budget constraints here, and this is your utility function. So try to find the optimal. Set this one equal to 0. Equal to 0. We will get minus Q, it's only show up here, right? Qij only show up here. Set this one equal to 0. So if you organize a little bit, oh, sorry, chain rule, I forget it. So should have Aij. Right? So if we organize it a little bit, you could turn to the page of 11. That's exactly this equation. That's the first equation we have on the page 11. Right? So this is, we get this equation by taking the partial derivative with respect to Qij. And think about that right now, I could be any country in the set. I and J are the country in a set, right? So now I just give another country a notation I plot. So by the same token, I take the partial derivative with respect to Q I plot J, and I will get exactly the same equation here. The only difference is right now, all subscript of the I become I plot. Okay, so that's two first order conditions. And what is the next step that we try to find out the optimal value? Usually, by using a Lagrange multiplier. We are going to divide each other, right? So this equation divided by another equation here. So we will get what? We will get a very clean format like this. So everything is in terms of their ratio, right? And just using algebra, we times pi plus j on both sides of the equation. And we will get what? We'll get this. Okay? From here to here is just algebra. So the next thing is we try to find out what's the relation between xij and yij and yi, right? But none of them show up here. So we need to aggregate it one more time. So Oh, sorry. Here should be I. Not J. So finally, we will get the left-hand side of the model here becomes yj. Why? Think about it. This is the trade value. This is the income of the country J, right? Or the production of the country J. If you sum up all the imported value from all other countries, the product between their price and their quantity, if you sum up, this is that will be country J's income. And this will be another term called price index, called Dixie price index. P is equal to so in all, finally, if you do the algebra and then try to derive it by yourself during the weekend, you could see that we arrived the final equation that looks a little bit similar to the gravity model. So yj again is the j's, country j's income. This is the demand shifter between ij. This is the quantity of trade between ij. This is the price of goods between ij. Last one, this one is the price index of country J. So now we finish the demand side of the model, which looks like this. But have we found out the equilibrium yet? The answer is not, right? So this is just demand side because we only use a utility function given a budget constraint, right? Find out Lagrange multiplier. So this is just the demand of the representative agent. So now we look into the micro foundation of the model. Okay, so in economics, if we have a demand and we try to find out the solution of the equilibrium, obviously we need to do what? We need to find out the supply. Right? So the supply, it's relatively easy here because we are just looking at the simplest Armington model. Let me go back to my file. So I'm here. This is the demand equation I already figured out. And so as you can see, equation 3 is the foundation of new trade theory. led by Mark Mellis and Armington model. Okay, so we need to construct the demand side. Demand, once again, has a lot of ways to construct the, oh, sorry, supply. So we need to consider supply now. Since we already have demand, right? And now we need to think about the supply side. So that combine these, we can find out the equilibrium of the model. So demand side, we already figured out by using the CS utility function and the budget constraint, resource constraint of the country. By using a Lagrange multiplier method, right? So there are actually a lot of the assumption, different kind of assumption on the supply side. So today we talk about the easiest one. It's under the perfect competition assumption, which is a little bit of the Ricardian model's flavor. So under perfect competition, as we know, price of the goods are going to equal to the marginal cost of the goods, right? So the marginal cost of the goods is equal to what? It's equal to the wage that you pay to the labor. Or you could say this is the cost of every production input times this is the transportation cost. In trade literature, this tau ij sometimes referred to iceberg shipping cost. And why is that? It's because, you know, during the shipping, the goods shipping from one country to that country, the goods might demolish. So it's like an iceberg. So they will melt down a little bit. So usually this tau ij is larger than 1. So as you could see, once we plug in this back to our demand side equation, we have a lot of information here. One, we have the technology in original country. 2, I have the wage in original country. 3, I have the trade barrier between the country. And that's exactly what the solution looks like. This is our demand. This is our supply. We plug supply back to demand. That's our Armington model. Okay, so let's pause and stare at this equation a little bit more. Trade between I and J depends on what? First term, the demand shifter between I and J, right? So if you have K, if you have industry K here, different countries, different trade partners, their demand shifter of the in industry K will be different. And it also based on what? The trade bilateral trade value also based on the cost of the production input in the original country. The transportation cost between these two pairs. The technology, production technology in original country. And important thing, the elasticity of the substitution of the different country. Also depends on the absorption of the destination country, the income of the destination country, and the price level of the destination country. So as you can see, I will close the model here. So as you can see, the simplest Armington model developed by Jim Anderson and Eric Van Koop, they provide a very elegant way to explain everything that we probably encounter in international trade. You want to talk about proximity, distance is here. Transportation cost, it's here. you want to talk about the endowment, the technology differences, it's also inside of the model. That's the reason why this is the managed model right now. Okay, I know this is a little bit challenging, but I just want to let you guys know that this is the modern trade theory that we are. You probably will see a second time when we talk about the monopolistic competition again. But if you have a time, go over the additional readings and then go over the derivation will be great. And we will take 10 minutes breaks and we'll go back and then go back. We will come back to the class and then talk about a little bit easier things that Ricardian model. Thank you. So we will come back at 7:52. Okay, so let's get back to the Finkstra and Taylor. This might be somewhat more more straightforward. So everybody ready? So this is the chapter 2 in Finkstra and Taylor, and the main topics. Oh, thanks for letting me know. By the way, thanks for letting me know that your feedback, so I could adjust a little bit of my materials in the future. In general, people feel a little bit hard for the derivation of the model. I don't know, it's because of the mathematic background or it's because of the economic training or what, but still some people think it's relatively okay. But I think if you go to the additional readings or like derive by yourself a little bit, it's not that hard as it seems. Okay, so let's move on to today's second part of today is the Ricardian model, which is covered in the um, Finstra and Taylor's book. So once again, still, anytime if you have any question, just interrupt me, jump out, or just speak up and jump into the chat room. And I saw one of the students are organizing the context. That's a very good idea from my point of view, because you will have to do the homeworks and homeworks you could discuss with each other. That would be a very good idea if you could have some of the study group or study buddy. Okay. Yeah, Mel.
Could you pause a little bit longer before you move on to the slides? I'm trying to capture all your notes, but sometimes you move a little fast between slides. Thank you.
I see. Yeah, sure. Yeah. Thanks for letting me know. That's something we have to adjust ourselves in this, like remote teaching stuff. Thank you so much for letting me know. Okay, definitely, I will do so. Okay, so in chapter 2, what we are going to learn is to learn what's the differences between the absolute value and absolute advantage. Sorry, absolute advantage and comparative advantage, and understand the very first neoclassical model that's called Ricardian model. And this model was named after Ricardian because he invented, and the core idea is about comparative advantage. So you have to compare what's the trade and what's the consumption of the goods and production of the goods under the autarky scheme. Autarky means what? Autarky means no trade. And then after the trade, your consumption and the production will be different. So that's the main point for today. So we already discussed this in the first part of today's lecture, right? So what are the forces for the trade? What are the forces that causing each country to trade with each other? The first one is technology. The second one is resources. The third one is the ability of the globalization, offshoring. The last one, which we just covered today, is the proximity. Right? So today's the most important thing is about the first one. It's the core of the Ricardian model. So sometimes technology could be represented as two ways. One is called just technology. The second is called productivity. You will see both these two terms in the questions, practice question as well. So when we address the technology, we usually say that one good needs like how many amount of the workers. So when we talk about the productivity, it's like opposite. We will say one worker could produce one worker could produce how many goods. Okay? So that's the two way to represent the technology. And this will sometimes be a little bit confusing. Offshoring, it's the iPhone, we already talked about this. And of course, we talk a lot about the proximities today. So in this chapter, the Ricardian model explains how the level of the country's technology affect the trade pattern. What is the meaning of the trade pattern? The trade pattern means which goods export which goods and import which goods. And also at what price. So that's the main idea, main goal if we learn the trade model. We want to know if we see some of the facts of the country, for example, their marginal productivity of the labor. If we see this, and we have two of the goods in one of the country, and we also see the marginal productivity of labor in foreign country for two goods. Could we use the information here to predict or to identify what are the goods are going to be exports? What are the goods are going to be imports? Yeah, Mel.
Oh,
Question?
sorry, I didn't take, no.
Okay, it's okay. Don't worry.
Oh,
Yeah. Don't worry.
thanks.
Okay, so some of the conclusion or some of the key points of the Ricardian model is what? In Ricardian model, we only consider one production input. Which is labor. Okay? So this makes my PPF. My PPF called production possibility frontier is a straight line. Okay? So if we move on to the next chapter, you will see the PPF no longer a straight line. So that means the one production input assumption, it's not going to hold anymore. But today it is in Ricardian model. So Ricardian model in some sense is two country model. And it's two goods and one factor. So sometimes it will be referred as 2 by 2 by 1. Okay? Okay, so you have to know what's the meaning of constant return to scale. I have to explain it today. So the four details of the four important things that we know to reason for the trade is what? The first, proximity. The closer the country are, the lower the cost of the transportation, right? So we see a lot in our gravity model that we just went over a couple minutes ago, and you see the cost. We call it iceberg transportation cost. Right? So in the books, it tells you that the largest trading partner of the most European country is another European country, and also the largest trading partner of the most Asian country are China and Japan. And for the U.S., the biggest trading partner are Canada and Mexico. So proximity play an important role. And resources, right? Resources. In the example of the textbook, use the ranking of the import snowboard to the U.S. So resources means what? Natural resources, labor resources, and capital, or some of the production technology. So one of the biggest examples that book shows you is, for example, Austria is the second biggest country to import the snowboard. So you can see why. Austria is a little bit far away from US, and because Austria is also very good at winter sports, so there are many factories they might be able to produce higher level of the snowboard. Then the next reason for the trade is called absolute advantage. So absolute advantage, you could just treat it as productivity is higher, or technology is more efficient. However, as we could see later on today, in today's model, absolute advantage is not a good explanation for the trade pattern. So what does it mean? The country, the country has the absolute advantage. The country will not always export the goods with absolute advantage. On the other hand, comparative advantage are something we are looking for. So what does comparative advantage mean? If a country have a comparative advantage in one good, means by producing that good, the opportunity cost is smaller to produce that good. Okay, so in a plain word means what? Means that country has relatively better technology in producing that good. So based on the prediction of the Ricardian model, the country will export the goods with comparative advantage and import the goods with comparative disadvantage. Okay, so let's jump into the model. First of all, we need to assume a home country. Okay, so home country basically we will refer as home throughout all the lecture today. So in Ricardian's original model, two countries he is looking at, he was looking at England and Portugal. And the two goods that Ricardian model originally looking at wine and clothes. So at the 19th century, Portugal have both advantage in producing wine and clothes. Means what? Means the Portuguese worker has higher productivity to produce wine, and the Portuguese worker has a higher productivity to produce clothes. However, Ricardo find out that actually England and Portugal, they still have a trade in both of the goods, in clothes and in wine. But this is a little bit counterintuitive. Why? Because Portugal has a better technology in here, has a better labor productivity in wine, and has a better productivity in clothes. England should always buy their their products from Portugal, but that is not the case at that time. So that's the reason why he developed this model, and find out that comparative advantage actually played a more important role than the absolute comparative comparative advantage of the goods plays a more important role than the absolute advantage in the goods. And since this textbook was authored by two American economists, so they switch a little bit of the target goods right now. One is still clothes, another is called wheat. So from now on, you could treat the home country as the US. So they assume that labor is the only resources used to produce goods. Okay, so this is kind of a ideal, right? Think of that, who is the labor for growing the wheat? It's the farmer. And who is the labor to producing the clothes? It's the workers, right? And their skill sets shouldn't be the same. So this is the big critiques in Ricardian model, right? The worker in clothes industry and the worker in wheat industry, they shouldn't be perfect substitute. They need to acquire a new skill set to move between those two countries. But since this is the very first model we take a deep look, so we just give in assumption arbitrarily. Okay, so in home we assume that one worker produce 4 bushels of wheat. So one worker produce 4 bushels of wheat, and in mathematical equations look like this: NPL W equal to 4. And we assume one worker can produce 2 yards of the clothes, so MPC is equal to 2. So remember that MPL stands for marginal product of the labor. Right? So if you're using mathematical equation, it should be like this. So MPLW equal to right? This will be those two numbers are just arbitrary. Okay. But remember that I told you in the beginning that productivity and technology, they are associated with each other. And sometimes very confusing technology. What does it mean? So one worker could produce 4 bushels of the wheat. That means 1 bushel of the wheat requires how many workers?
A fourth a worker.
Yeah, quarter, right? So this we're using productivity as a representation. Here we use technology. By the same token, 1 yard of the clothes in home country require it's gonna be a half, right? Okay, cool. Yep, somehow my connectivity has some of a problem. Okay, good, thank you. So that's just a different way to show the productivity and technology. Good, thank you. And let's move on to the next slides. So after doing this, we know the marginal productivity of labor in 2 goods. We could draw out the production possibility frontier. So for example, here, we assume that if home had 25 workers, right? So total worker of the home country are going to be 25. And we already know that the NPL, marginal productivity of labor in wheat, are going to be 4. Marginal productivity of labor in clothes are equal to 2. So how do we draw the production PPF, the production possibility frontier? If we put wheat in the x-axis and we put clothes in y-axis.
For the clothes, you can produce 2 units, 25, so put a mark at 50, and then 4 times 25, 100 for wheat on the x-axis, and draw a line between the two.
That's right. That's right. That's exactly right. So if I put all the labor I have into the clothes industry, I could produce 50 yards of the clothes. So here it should be 50, right? And this is calculated by L times MPLC is equal to 50. 2 times 25 times 2 is equal to 50. The other way around is the wheat. Wheat are going to be 100, and this is calculated by 4 times 25. Right? So what are the most important information we should know? It's the MPL wheat, MPL clothes, and the total labor in home country. If you know these three information, you could plot out the production possibility frontier. Okay, so let's take a look at what does it look like. It looks like this. As we said, 50 is if we put all the labor to produce clothes. If we put all the labors to produce the wheat. Okay, and one more important thing is, what is the slope of this PPF? The slope of the PPA, the slope by its definition in mathematics is the rise over the run, right? So it's the ratio of this section over this section. So here it should be 50, 100. But remember that because they change at a different direction, you need to put a minus sign here. So this is a negative slope PPF. What is the economic meaning of this minus sign? That means it's something you have to give up, right?
It's the opportunity cost of producing wheat is you're giving up a half unit of cloth.
Yes, exactly right. So the economic meaning of this minus sign is something you have to give up, right? So give up. That's the opportunity cost. But now we just focus on the value will be fine. So in order to produce one more unit of wheat, you need to give up a half unit of the. In order to produce one more unit of wheat, you have to give up a half of the clothes. Okay, so that's basically the first part of the Ricardian model. So we already done the supply side, right? So where are we right now? We have a home country's assumption, and we have the supply, which is captured by the possibility production frontier. And the next thing is we need to capture the home demand so that we can find out the equilibrium, right? So the demand, we use one of the tool called indifference curve, or IC. So everything on the indifference curve means what? This two consumption bundle will give you the same level of the utility. If you have already taken the microeconomic courses, so what are the normal shape of the indifferent curve? It looks like this. It's a convex curve, right? But this is not the only one. Some of the indifferent curve might look like this. This happens at what circumstances? And what about this? This is
Complementary good for the middle one, like left and right shoe.
perfect complement good. And this one is perfect substitute, right? So if you see the utility or the preferences is like alliative preferences, you should draw your indifferent curve like this instead of using this one. Okay, but all of them have the same characteristics. What is the point here? If I have two utility level, which one is higher? U2 are going to be larger than U1. And this could be compared by this. If X and Y all brings you the positive utility, A and B should have the same utility level because they are on U1. But C and B, the differences between C and B is C has a higher level of the Y goods but have the same amount of the level of X goods. So C should larger the utility at C point should larger the utility at A point. That's the reason why U2 is larger than U1. That's the reason why points on a higher indifferent curve have a higher utility. So you see in a normal state in conventions, okay, utility means the level of satisfaction. If I have a good two goods and I want to draw or I want to delineate my level of this happiness of buying those two goods, I will use the indifferent curve like this. Does that answer your question? So buying goods give you utility, right? Give you utility, different bundle of the different bundle of the goods. If they bring you the same level of the utility, they will be on the same indifferent curve. And infinite, those bundles will be like a line for the indifferent curve, become an indifferent curve. So in conventions, normally indifferent curve will increase, the utility will increase as the indifferent curve moves to the northeast direction. If X and Y brings you the positive utility. So let's see what's the equilibrium right now in Hong Kong. So here, the production is here. Production is delineated by ppf. Right, so this is the supply side production. And utility function is here. This is the demand side. So if you already take the microeconomics, you should know that the tangent point here should bring you the maximization. Why is that? It's because if the point is here, you didn't achieve the maximum utility. Right? So U1 is larger than U0. So B is on the U0. U0 is smaller than U1. So for a rational consumer, you should switch your consumption bundle from this, from B to A, so that you could cut your indifferent curve here, and you can get the higher utility level. right? And think about that. Why C cannot be the optimal point here? It's simply because C is outside of the PPF, right? C is not reachable because C is not in the production possibility function. So the equilibrium in autarky area in home country are going to be A, the point A, and that is the consumption bundle of 50 bushels of the wheat and 25 yards of the clothes. So if you take a step back and think about it, this is really similar to the consumer's question, right? What do we call this one? What do we call this line in consumer theory? We call the budget constraint, right? And now you could think that this is country's budget constraint, or this is the country's resource constraint. And this line is the countries in different curve. So how do you find out the equilibrium point? Find out the tangent line. Okay? So then we move on to the hold on. Should go to we take a look of the detail of the PPF. So the slope of the PPF reflects the opportunity cost of producing 1 bushel of wheat. Okay, so remember that it's the opportunity cost of the x-axis good. That is the slope. Under perfect competition, the opportunity cost of wheat should equal the relative price of the wheat. Why is that? Think about it. If we have 2 industries, one is clothes, one is wheat, and we have to pay their wage for their workers. So if the workers, they can move perfectly between the industry, those two should be equal, right? So this is one of the important conditions for the perfect competition of the labor, because they can move from this to this freely. If the wage in clothes is higher than the wage in wheat, more workers will go to clothes industry because it's perfect competition labor market. There's no entry, so that will cause excess supply of the labor. So eventually the wage will decrease in the clothes industry. And because the worker was drained to the clothes industry, less and less worker remain in the wheat industry. The wage in wheat industry will increase. So this is a stable equilibrium condition. Okay, and then let's take a look why the other equilibrium in the market. The wage of the worker in this industry, it's equal to what? Equal to the price of the goods times the marginal product of labor of that good. Why is that? think about it. This is how much quantity of the goods produced by one of the labor. And this is the wage of the labor. So at the left-hand side, this is the cost for the firm. On the right-hand side, price of the goods times marginal product of labor of the goods. So this is quantity of the goods. This are going to equal to the revenue of the firm. Right? So under the perfect competition assumption, the firm's cost should equal to their revenue. That's the reason why this are going to hold. And we already know that under a bigger structure, this are going to hold too. So we will have WC equal to PC times MPLC equal to P MPLW. So if we take the middle part of the equation, this is something we are looking for. Okay? So this is basically what I have just said. In competitive market, firm hire work up to the points at which the hourly wage equals to the value of one more hour of the production. So that's which one? If you take a look at the wheat industry, that's equal to P wheat times if you take a look at the wage in close, that's this. And we know that the wage will be equal across the industry, so that we could put this together like this, and do a little bit of the algebra, put C to the denominator, this to the MPLW to the denominator here, you get this equation. So what's this? The relative price is equal to the opportunity cost. So this, something we already see in the PPF, it's the opportunity cost of wheat. This is the relative price of wheat. So once again, this shows the spirit of perfect competition, right? So P equal to C again shows up here. So let's move on to the foreign country. So we already done the home country part. As I said before, this is a two-country model. We need to take a look at another country. So by assumption, this country has the MPL of the wheat is equal to 1. What does it mean? In foreign country, one additional worker will produce 1 bushel of the wheat. MPLC equal to 1 means one more worker you hire, you could produce 1 yard of the clothes. So remember that the notation here, if we see the asterisk here, it's usually it's represent the foreign. Okay, and now we assume that the foreign country has 100 workers. So what do we write it in mathematical equation? So once again, if we know the marginal product of labor in two industry, and we also know the labor endowment, we can draw out the production possibility frontier again, right? So this will be the production possibility frontier for the foreign country. And this is drawn out based on the information of MPL C star equal to 1, MPL W star equal to 1, and L bar star it's equal to 100. So what is the slope here? This is the slope of the opportunity cost of producing the wheat in foreign country. Okay, so we've done another supply side of the model in foreign. What's next? We try to identify the equilibrium, so we draw out the indifferent curve of the foreign country. So once again, you can see this one is the optimal point under the autarky system, autarky in foreign country. So let's conclude the model. Let's go back, wrap up a little bit. We start from home country by knowing the MPLC, MPLW, and the total labor endowment in home country, so that we find out PPF, so that we have the supply side of the home country. Then we're using the indifferent curve to construct the demand side of the country, so that we can find an equilibrium in home country. And it's the same thing in foreign country. We firstly see 2 MPL and L star bar. So we have defined the supply side of the foreign country. Then we need to identify their indifferent curve, IC again. So we find out the foreign country equilibrium. Okay, so now we already have the consumption bundle and the production bundle under the autarky scheme. Under the autarky, I want to finish this today. Okay, we won't go into the trade part. We will pick it up next Monday. Under the autarky, there is one feature you have to know: production. It's always equal to the consumption. And by I mean production. It's mean production bundle. Wheat and clothes are going to equal to the consumption. So in next week we will talk about why the trade will bring the utility up. You could think about right now. Right now, I have two countries. One is home. Let me share the platform. So I have two countries. Given the information I have, I know that my PPF at home should look like this. And based on my indifferent curve assumption, I produce and consume at this point. That's called A. In foreign country, it's the same story. The only difference lies in the opportunity cost. Right, so as you could see, this triangle here in home country, this triangle here, the slope is flatter than this one. This angle is smaller than this angle. That means what? The opportunity cost to producing wheat is smaller than the opportunity cost in producing wheat in foreign countries. Home country's opportunity cost in producing wheat is smaller than foreign countries' opportunity cost to producing wheat. So based on this, based on all the discussion we have, who has the comparative advantage in wheat?
Home country.
And who has the comparative advantage in clothes?
Foreign country.
That's going to be the foreign country. Right? So comparative advantage. Oh. So what does the Ricardian theory tell us? The country will export the goods, have the comparative advantage. The home country will export the goods, they have comparative advantage, means the smaller opportunity cost, which is wheat. And the foreign country will export the clothes. So we only have two countries in our model right now. Home export wheat, import clothes. Foreign export clothes, import wheat. That's the ballpark of the description of the Ricardian model. We will talk about how do we determine the price and what's the gains from trade next week. I will have the office hour tomorrow, and then sorry about a little bit of the technological issues. And if you come in too late and you want to count in the attendance, please let me know the reason why. And I will stay here for a bit, but the class is dismissed right now. Thank you all.